Hi everyone, Alex is here, and today we'll be talking how we can create a basic prediction app. So let's start with our project. We have our favorite CLI folder, our SRC folder. So let's check with our CLI. Firstly, before starting, we should create our virtual environment. Why should we do that? That's all because we need to store all our libraries that we'll import inside our project. So we won't have any troubles with your global libraries or some conflicts or something else. It will be working stably and good. So, for that, we should firstly install our virtual environment. Let's copy that. Let's open our terminal and put it. It instantly asked me if I wanted to create a virtual environment. I don't want to make it right now because I wanted to make it with our CLI command. So then we should create our virtual environment. And for that, we're just using virtual env that we have created and then running our folder name. So it will be venv. It's short from virtual environment. So that's like usually the most common name for that thing. Let's copy that, put it here, and voila, we have the one. And it instantly tells us if we wanted to select it and work with that. And this is one main difference here, that when you're creating a virtual environment, you should connect to that. Why should you do that? Everything is simple. Just understand that we have created virtual environment, but we're still working with our global configuration of Python. So we should go to that specific virtual environment. So let's go to activate venv. And here we have two commands. One for most Mac Linux users, another for Windows users. There is quite small changes, but they're important for working on Windows. We're just copying what we do for Linux Mac users, and then we're just putting that into our terminal. And we have that. How you can understand it? Before your terminal name that has been before, seen in round brackets our environment. That is the folder's name, venv in our case. So that's what we have. Amazing. And let's go to install libraries. We should have TensorFlow, Pandas, and Scikit-learn. Why? We'll discover that while discovering the main page. So just copy that, pasting it here, and let's wait for a while. It shouldn't be too long. It's just a couple of libraries, and that will be nearly all. TensorFlow is the largest one of them all. Let's go to the last one. So after all that, we just should run our AI. So we can go here, and for that we're going to our SRC folder and running our main.py file. Quite easy. But I'll put it here. No. Or yes. I'll put it here. I'll make our terminal to one line. And let's finally go to our SRC folder and let's open our main file. So let's open that. We can hide in general our SRC and in general all of that sidebar. And that's all our program. It's not long, as you can see, it's just 49 lines of code, but with all of that, you can create your real predict system that will predict, for example, in our case, prices for living in specific apartments. What should we do? Firstly, we're importing our Pandas, TensorFlow, and Scikit-learn. What should do what? Pandas, mostly, is for calculating on metrics. So we'll be using DataFrames. And DataFrames is just metrics. What is that? It's list inside of the list. That's all. That calls metrics. And it's always been using in our AI for better understanding context and working with all of our files. So what should we do? We're just loading and preparing our data. For that, we are using predefined data frame, but mostly we're just taking CSV file. And we're taking CSV file more often than we're taking any other table data. Why? CSV is extremely easy. It's just comma separated values with all of the values on the next line. XLS or other tables, they're more complicated. And especially when you're working with a lot of data, you'll see significantly that CSV is easier, totally easier. It will be faster for downloading file, for running that by your machine, and for training, and even for predicting when you'll be predicting. But okay, maybe predicting not, but definitely by training and testing, that will be definitely worse to have that in CSV. So we have such way of writing. So we'll be working with size, square feet, bedrooms, and price USD. First, what we're creating? We're creating data frame. What it will create? It will just create a list inside of the list that will have a couple of lists. You can check it here. So it will be just easier for us to work in, and the most important for AI, it's the standard to working on that. Then we're working with our X, features, and target. What is features? It's with what we'll be predicting our data. So something will be given to us, and something we should give back. So this something that is being given to us is square feet and bedrooms. And price USD is the thing that we should give it back. So we're just dividing that and taking this data from our data frame. Then we're splitting data set for training and testing by using training test split. It's Scikit-learning method. So basically what does it do? We have our 4 variables: xtrain, xtest, ytrain, and ytest. Why should we have that? Because firstly, we'll be training our model. For that, we're taking x, for example, 1,503 bedrooms will be this price. So it just takes these 3 and gives like these 2 numbers will give this in result. These 2 numbers will give this result. That's the crucial thing that you should understand. That splitting that will say us as a teacher, we're teaching that these numbers will have such target. For testing, we'll have vice versa. So our student model will have 2 numbers and think that maybe something will be another number. And then we'll be given the real truth. What is the real number? So for example, we're given these 2, and it thinks it will be 1 billion, but it's not. It will be this price. So this one will be Y test. And with this Y test, our model will understand how correct is that. Yeah. Let's go further. Standard. That's important thing that with which we should work. So an idea of all the models, AI is our model, for you to know. So AI is not something very abstract. It's a model, it means it's a file that mathematically calculates what we wanted to have. And the result is also mostly in numbers, and then it's sometimes converted to image, sometimes to text, sometimes to some actions, but basically it's all working with numbers. So that's why there is a huge main idea. AI is mathematical weights, some mathematical calculations, etc. You can discover that by your own. Important thing that when you're working with numbers, and there is a big difference, especially when you're comparing something, it's not so good. So what will be standard scaler do? It will take our data and make it from 0 to 1. It's standard for working with your AI. Of course, some models can work in different way, but that's the most reliable and the most working method that you can do. So you're taking, for example, these numbers and these numbers. And we should say, for example, 5 is a big value in this list. And for example, 3000 is also a big value in this list. But 1400 is the last value in this list. And 2 is the last value on this list. So we should say somehow that this is not so big numbers, like it should understand it's big, less, it's good, like it's top or it's bottom. So this scaler will help us with that. So what does it do? We're taking X data, so we're taking only this data right now. And we're taking training data. And we have here one difference. Fit transform and just transform. This is for test, this is for training. Let's firstly start with our training. We're taking scalar, fit transform, and our list of X training data. Also, I forgot to tell you an important thing about test training. So we have test size 0.2. It means that we're using 20% of the data for testing and others 80% for training. It's one of the rules that calls 80 to 20s. 80 for training, 20 for testing. And in our case, it's just written with 0 point, because 1 is 100, so 0 is 0%, so 0.2 it's 20%. It's basic percentage formula. And that's how it is being divided. For some different situations, you can use different way of working with that. It's just standard one. Then random state. If you know, miser, it's not so random thing, because we don't have something random in our life. And when you're going to some website and there is random numbers, it's not really random. Basically, it's been taken on your, I don't remember, or CPU or GPU, and then it's calculated by your time, and then it just divides by itself, and then you're just saying the range that the number should be, and in such a way it's the random number. So something like that. Random number can be really find out. And the problem is that train test split, it splits data in the random way. And here is the problem. We should have nearly every time the same results, so we'll be able to understand how we can upgrade our AI, because AI is not being trained once. We're training that a lot of times during one day to understand how it will be working the best way. So for that, we should always have the same training methods, the same data for training, but it should be random, so our model won't know what we are training it with. So random state just gives a number that will be this magic number that will help to randomly divide that, but it will be always equal. In general, you can write here any number, but 42 is just what I have been learning with and using that, so you can try others. But that will make the next thing. We'll be taking random data from this list, but it will be always taken in the same way. So For our testing, it will be every time when we will be rerunning that, the same approximately image. And that's good because we can understand how we can improve our model, because if it will be really randoming, every time running our tests we'll be having different results. So sometimes we can have just 60% of loss, sometimes 60% of good working. So random state will help us to be sure that data is taken random, but every time when we'll be rerunning the model, it will be taking the same random data. So we'll having the same results approximately, and we'll be understanding better how to improve our model, because we'll be relying not on the data that is being taken for training, but on the real upgrades, real layers dense, real activation methods, etc. and etc. So that's important thing. Let's go back for our feed transform. So transforming will take this data to 0 and 1. So 0 will be 2, 0 will be 1400, 1 will be 3000, and 1 will be 5, approximately. And then it will better understand how does these numbers works between each other. So what will be if we'll take in bedrooms 1 and square foot 0, for example? It will understand that it shouldn't be a big price, because one value that is important big, another one is less, and then it will compare which list is more valuable. So that's the thing. And fit, just this prefix, means that we instantly put this thing into the data. Our model instantly access to that list, something like that. But here transform, our model should not know about that. And that's why just the method transform. We are not feeding it to our model, because if we will do, the problem will appear that our model will know which data give it. So it won't test it out. It will just write the correct numbers, because it will be not like test data, it will be like train data. So for test data, we're just using transform, not feeding it to. And that's the most preparing side that we have created. And right now will be the most interesting, the most hard and easy in the same time way of creating any AI predicted application. So here you can see build and compile the neural network model. For that, well, in general, what's that? It's something like a brain and how our neurons are working with each other. So basically, it's how we are thinking. We're thinking with neurons, and it's a small computer example of how it should work. So we have some layers. One layer, second layer, third layer. And that will show us how we can rectify, for example, how we can show some data, how it will be calculating, and etc. etc. And for example, basically, the first layer always is input, like which data will be input. And if you'll imagine this graphic, it will be first two. Then we'll have a layer with 64 neurons. It's the question how much you should use them. Mathematical models will give you exact numbers, which is better, but mostly it's experiment. So you just should experiment. And then you're working with activation. So activation between input and your 64 neurons is, what does it mean? It means that these data are not always properly to each other. For example, 3 and 3 and 3 will have different numbers here. 1,500, 1,800, 2,400. And that's why we're using activation rectified linear unit. It's the mathematical method that will compare the data as not to be 100% equal. So if we have, for example, bedrooms 3, it won't expect that the size square feet will be always 1500. Because in this way, it will be linear one that we're using in the very end. You see, there is nothing activation. It means linear one. And you will understand why. So then you're taking the second dense, that is more often it's a less number than it was before. Sometimes it's like in 2 times less. Sometimes someone is going sometimes for 16. Is mathematical, you should take some courses on neuron thinking on the mathematical way, not programming, because programming, it's all what I am showing to you. It's nothing here. The most important is mathematical models and formulas that you should use. And that's why to be AI engineer, it's more about working on the mathematical way, writing formulas, not writing the code. Thanks to Python and the libraries, right now it's extremely easy. You should concentrate on the methods that you're using, mathematical models. Yeah, so let's go. Then we have 64. We say that it's not like these numbers could not be equal to each other. I mean, square feet and bedrooms. And then we're going down to 32. It means that it should understand, like, how you want to say, better understand what is on the top, what is on the bottom. I'm not very in, honestly speaking, of which dance will do what, but that's approximately how it should work. And then activation relu means that we are checking it with the previous dance. So previous column of neurons, this column of neurons, we have linear connection between the old one and the new one. And right now we have 1. What does it mean? Always the last dance mostly will be linear and will be 1, because mostly we're using for one answer. For example, the weather prediction, we're looking for one specific answer. It will be rain or it will be shine, for example. But it can be some data, for example. We have a couple of data that we're giving to our model, and it gives us humanity, what will be the weather type, what will be degrees, what will be vision, for example, for which distance it will be. So it can be a couple of more difficult models, and the dance will be quite different here, depends on how many values you wanted to have. But the most easy one to go with one result from our model. Basically, for the last dance, we're using activation linear between our not last column, like the one that is going before that, 32, and then says that it will be one answer. Why linear? Because when it collected all of that, understands the difference of which numbers will give what, it will have straightforward answer. So straightforward answer means that it basically won't be depends on it's even hard to say, one sec. It won't be dependent on the data that hardly, sorry. So I'll say in this way, linear, just say that the data will be straightforward to the result of price UZ that we should have. So if it's 1,500, 300, it will be this price. It won't be another one. If the square feet is this one, and we have such answer, it will be straightforward this price. And that's the thing how it will work. So with based on a lot of parameters, it will be understandable 100% such price. If we're taking that in real life, we have a lot of the problems with the mood of the buyer, the mood of the seller, the weather outside, the place where it's living, and it's not always will be a linear one, but in most cases, in most especially AI programs, it will be using linear one. That's how dense will work. And to say that, okay, it will be going in this way, we have a structure for our brain, how it will work. So we have optimizer and loss and compile. What does it mean? It means that while it will be running, we will be optimizing our app, our model, with the ADAM methods. It's one of the mathematical models, and the loss will be mean squared error. So what does it mean? It means that it will compare, for example, it's going the first time. We gives that the data to train. It's like, okay, that's what I understood. Then we're giving test data. It gives its prediction that will be very bad, extremely bad. And what is optimizer ADAM gives us? So it takes a error that we have, and this mathematical model, it says how we should change our weights so it will fit this data. What is weights? Weights is a mathematical way that is between this activation ReLU. So ReLU activation, and we have the weights, it's just the numbers. Sorry, we'll repeat it because of the interruption. So optimizer will update the weights, because weights are the thing that basically creates your model, because weights are the numbers after your model thinks, okay, we will have these two numbers that are taking us to input. We have a lot of different numbers for all the 64 neurons. And this like multiplies, divides that, and then it has a lot of other numbers, and by dividing them to numbers, we'll have numbers, and then it just takes the biggest one. So it's something like that. So this optimizer, and I'm just change that weights. So after a lot of tries, these numbers that are making this activation will show us the final great result. Mean squared means that it will like square there that we have. So it's important to understand which percent of the how big is it with our real value. And while this is one of the hardest part to understand, it's one of the most important by mathematical side, then we have something easier. We have our training model, training that is complete. It's like history, model, fit, and we're fitting our training scaled data. Then we're putting our Y train that we should train on which, like the correct answers. And epochs 150. So what does it mean? It will mean that it will try 150 times to understand the numbers, because then it will be another numbers. It will be taking every time these epochs different numbers. So it should fully understand what means what. So like how many times it will be better, it will be good, but don't make overthinking for the models. It means when you will have, for example, such number, it will just remember these numbers and will always send these numbers back without ever any thinking of something, overthinking. So 150 is a good gold number in our case. You can discover better one with mathematical methods too. So verbose means that we'll show or not our training. And you know what? Let's show that. And then we have evaluation the model. So it means that we'll take in our test and Y test and discover how big is our error. So how bad does it understands our results that we should working with. So that's there. Here we'll have our answer. So here we'll have training that it will test with a couple of values, 20% of the values, and send us back how many in percentage way errors do we have. So we should just square that and we'll have, or take it from the root, something like that, and we'll have percentage value. Okay, so then we can predict it with taking one of the square feet and the bedrooms, and then we should also transform that, because if we'll put this data in this way here, it won't understand it, because all the data that we have here we have taken to scalar, so it's different right now. So we also should put them to the scalar. And then we predict, and then what does it mean? 0, 0. It means that we're taking that from the matrix, and for first value, we have 0, the value that it gives us back. And let's run it to figure it out. And let's check also the test model, so you will be able to see the full image, how will it work. So let's run it, and you'll see. Let's wait a little bit, and you'll see here how our testing is going, because before that it's creating this sequential, it's trying to transform that, or we have some weird find here, I see. Okay, so we'll see, maybe some additional apps are trying to be run, so currently we'll be waiting for that. But before that, just for you to know that mostly it's not the Python file that we'll be working on, but Notepad. What is Notepad? Notepad is something similar to MainPy, but you can have cells of running specific lines of code. Why it is created in that way? Because when you will discover that, it takes time. Oh, you can see. It have taken time to run all of the things. And not to waste it, because if you're taking a big model, it can compile sometimes for a couple of hours. Some models have been even compiling for weeks, even months. So, and if you wanted to change one, to have one little change, or to take the same model and just rerun one of the tests, of course you don't want it to every time to run all of the process. So that cells will help you to work with specific parts of your apps. For example, you have compiled the model, you have it one, and then you're running the test, and you're just adding cells on the bottom, or you're just changing some that have been worked already. So the other thing, can you imagine the problem when all of your model has worked, but then you have written print without T, and it gives you error? I have that once upon a time, and after that I realized how good Jupyter Notebook is it. So we'll be using that a little bit later, but for now we'll be just taking our main.py file as we have. So Apex, like, it's trying to run in that, and that's the loss that we have, and the most important thing is to see that this loss is going down. You can see 66, 62, 57, and it's going down until we have, for example, this one. And before that we had 15064. Right now we have 1504. So it has less loss. So loss is our problem that we have, and the biggest problem in our training is we have very small amount of the data. It should be really a lot of hundreds, even thousands of the data. So it's really important to have. After we have tested everything and we're running the final one, so this one, we have the square root error. It means that our testing was quite good in the case that it runs our prediction, and for this square feet, for bedroom, it thinks it will be $19. That's all, of course, the data that we have, and how small amount of that we had, because we have 4 bedrooms, that is 200 for that, and for example 3 bedroom for that is 2400. So it's not really understanding why it should be different. But in another way, you to know, it's with dots that we have, so it's a little bit better situation that you think. Yeah, so it's either way, how does it think? That's quite all for today. So you should understand that right now AI is less about coding, it's more about the formulas that you specifically are using. That's how it works. Thanks everyone for watching. Wishing you all the best and see you in the next videos. Thanks for being here. Bye.